Okay. All right. Time is 7 o'clock. On behalf of MTC Global family, I extend a hearty welcome to all the participants for today's workshop on structural equation modeling. Ma'am is there with us. Ma'am has already joined. Welcome, ma'am. Dr. Anubhuti, ma'am. It's pleasure to have you with
Thank
us
you, sir.
today and tomorrow. It's my great pleasure to briefly introduce ma'am to all the participants. Dr. R. Anbumati ma'am is currently associated with VIT University, Chennai campus. As associate professor, prior to joining VIT University, she was with Great Lakes Institute of Management between 2015 and 2023. She received her PhD from Pondicherry University as a UGC JRF scholar. Anbuvati ma'am did her chemical engineering from Pondicherry Engineering College and did her MBA from SMVEC, an affiliated college from Pondicherry University. During her tenure at Great Lakes, she was exposed to the world of analytics, and her curiosity towards statistics as well as maths made her passionate towards the analytics stream. She has got hands-on experience and guided students in their project work dealing with chatbots, natural language processing, deep learning, and data visualization. She has presented and won Best Paper Award in some of the national conferences and have book chapter as well as journal publications to her credit. Thank you, ma'am, to have you with us. And now I kindly hand over the session to ma'am. Kindly, ma'am, please.
Thank you, sir. Thanks for your warm welcome. Good evening, participants. I am Dr. Anbumati. I am presently associated with VIT Chennai. So, I think sir has given a brief introduction about myself. So, let us go to the session. So, the session is planned for 2 days. The first day is about we get the knowledge about what is structural equation modeling and what are the different types of structural equation modeling and something about the Smartpls. In the second day, tomorrow, we will get to know about the mediation and moderation techniques as well, how to do it at Smartpls. Okay, so before that, I would like to know about you people. It's like what about your knowledge level or your understanding level in case of Smartpls. So I have launched a poll. So I request you to take the poll and give us some insights. Like I would like understand about you. Can you please give? Okay, partially known about the technique. Okay. Okay. Yes. I request everyone to give your response, quick response. Okay. Yes, I got only 8 response, but I can see 22 or 21 people in call.
Hello, ma'am. Ma'am, I can't find that link. Where did you?
No, it's like I have launched a poll in Google.
In the chat group, chat box it is?
Yes.
Okay, but I can't see.
I can't see.
Okay.
You can't.
No, ma'am, I can't see in the chat box.
It's okay.
But I can talk about it.
Okay.
I
So it's like you know about the technique or you are very new to it?
am new to this, ma'am. I've seen a lot of papers using. So I've read papers which have used SEM PLS method, but I have never used it.
Okay.
Yes.
Okay. So I'll end the poll since some of you are telling that you can't view it. I'll end the poll. Okay. So it's like I have seen 2 of them have got partial knowledge about the SEM and that to pass Smartpls. So we'll start rather than I'm asking the question. I got to know what I can start now. Okay. So Is the screen visible?
Yes, ma'am. We can see the screen.
Okay. So, Smartpls is actually a technique or a Smartpls is actually a tool where we use for the structural equation modeling. So we will start with what is structural equation modeling first. Okay. So the structural equation modeling is a multivariate data analysis method. So you all know about regression. How does regression works? How does regression works?
No, madam.
Can you hear me? Okay. So you have known about the independent variable and the dependent variable, right?
Yes, ma'am.
Okay, 1 minute. Okay. You have known about this IV and DV, right? IV and DV. So regression is actually the relationship between the IV and DV. It's like you have seen this function y equal to mx plus c, where this is actually a straight line for regression, where y is the dependent variable and m is the slope and x is the independent variable. So generally we have multiple independent variables and one dependent variables in the starting. Nowadays, we do have more than one dependent variable also. So, in that case, in case of regression, even if it is multiple linear regression, you have this y equal to mx1 plus mx2 plus mx3. It means that you have one dependent variable and you have multiple independent variables. Okay, but when you have multiple independent variables also, there is a problem with this epsilon. We generally call this as epsilon. Epsilon is said to be error, where when you add more independent variable, the error term will be inflated. So this is what regression is. So when we are doing simultaneous regression, then it is called as structural equation model. Do you understand? If you have only one regression, it's like one dependent variable with many, more than one or more than two independent variables, then it is said to be structural equation modeling. When this regression have run simultaneously between any type, any dependent variable and independent variable, then it is said to be structural equation modeling. So we have univariate analysis technique and multivariate analysis technique. So structural equation modeling is classified under multivariate data analysis techniques because we are employing more than one variable. Okay. So according to this definition, the SIM structural model was earlier started in the marketing research. Only the marketing research, we generally started using the Smartpls. But later, due to its actually, it is very easy to do a Smartpls. It's like the PLS-based structural equation modeling. So the structural equation modeling is a multivariate data analysis technique which were used in marketing research. What is SIM is that the SIM is simultaneous running of the regression. So this is what SIM. So in SIM, you do have two approaches. One is CB SIM. We call as CB SIM and PLS SIM. CB SIM and PLS SIM, where CSIM is said to be covariance-based structural equation modeling and PLS is partial least square structural equation modeling. So, the structural equation modeling started with covariance-based SIM, where we use the software packages called Lizrel and Amos. Okay, M plus some might have used because I have hands-on only in Lizrel and Amos. The second approach is actually the PLS-based SIM, where it is based on the analysis of variance and it was usually carried in the Smartpls and Pls. I haven't seen people using this PLS graph or visual PLS, but generally we will do in Smartpls and Pls. And there is also one more module where this either both PLS, that is CBSEM as well as PLSSEM, we can use it in a R statistical software package. Since R is open source, they started using this PLS, that is PLSSEM and CBSEM in the statistical software packages. These were the two approaches of SEM. Okay, so why the CBSEM and why this PLSSEM? So I'll tell you the evolution of it. Okay, so the CBSEM, it is covariance-based SEM, started with this Amos Lizrel. It started with Lizrel. Why started with Lizrel? But what is the challenge when using the CBSEM? It's like where our title of the program also tells it's like a mediation and moderation. That was not possible when it was launched in Lizrel and Amos, and in particular CBSEM. And we need to run the model in either Lizrel or Amos, and then extract the output of it and import it to SPSS. You people have used SPSS, right? Yes?
Yes, we have used.
Okay, so in SPSS, you have a plugin called Process. You can plug in and find out that. So that is what earlier, it is like before 15 years, we were doing like that. So after that, it is like after Lizrel, the Amos was introduced, and it was quite good. It's like quite good in the sense it was comparatively easy compared to the Lizrel. But what is the problem with the CBSEM is that it will converge only if you have a larger sample size and normal distribution of data. So larger sample size means you have heard about the rule of thumb. It's like for one variable, you need to have 5 as a sample. One item, you have 5 as a sample. So it's like if you have 5 independent variables and 1 dependent variable, in case of CBSEM, you at least require 600 sample to get converged. So converge means it's like you have goodness. So you might have heard this way, or you have seen this, the goodness of fit indices, etc. So in that case, you need to go for larger sample size. As researcher, we all know that in case of primary data collection, getting 50 responses itself is a challenge. And even if it is 50 responses, the 50 responses, we will be having some skewed values, like some of the respondents would not have read the question and just mark the answers, etc., etc. So that is all the problem, real-time problem we faced. And again, it is like the CBSEM works only with the simple model. Like complex model, you have heard about moderated mediation, mediated moderation, etc. So CBSEM will work, but it's like quite difficult. It will be challenging. In the starting, we were getting the result and we use the process macro, plug in, and then only we will get the result. Now they have improvised it, but that was a challenge. Still, it is a challenge in case of CBSEM. But in case of PLSSEM, it works well with small sample size. What does that small sample size means? Even if you have 150 or 200 as sample size, you can run a PLSSEM and get better results. But what had happened in the starting, only in marketing, and that too after 4-5 years, only in marketing they were supporting this PLSSEM because they told that it was not rigor. Whatever you give the data, it will get converged. So they told that the rigor is very poor, while the CBSEM, the rigor is very good. And before 10 years, when I was doing my PhD, the acceptance rate of PLSSEM is very minimal. I can't tell that there is no acceptance, but it's very minimal. Only in case of marketing, they started accepting it. In case of HR or the operations or behavioral finance, they didn't approve it. Once we send a paper with PLSSEM, they tell that the rigor is very poor and they will not accept it. Okay. And one more thing, but nowadays it's like when you see structural equation modeling in many of the articles, even in A star, FT50, you can see that most of them have used the PLSM rather than CBSEM. Because now we are moving towards the complex model rather than a simple model. So when it is simple model, and our research is exploratory research. So in case of CBSEM, you can develop a model when the theory is perfect. Okay, you can develop a model when the theory is perfect and you can connect the theory. Okay, when the theory is perfect, and you can connect it with the variables you have considered. But in case of PLSM, it is like you can go for exploration. Even if you know the theory partially, you can go for the exploration in case of PLSM. That's what it is told, that the correct model specification cannot be ensured. So, and one of the, what is that? The PLSM have the advantage of small sample size. But what the researchers were doing, it's like, since it is told small sample size, they were testing it with 100 or 150 as sample size. That is also one of the reasons that most of the good journals, like A-star journals, were not accepting it. But it's like before 5-6 years, I've seen most of the A-star journals are accepting the PLSM. So again, in case of PLSMs, okay, before explaining this, I'll go to, okay. So in case of PLSM, okay. In case of PLSM, we can go for the exploratory research where you can know about the theory to some extent and you can explore it further. And one more thing is that the PLSM starts with the Smartpls software. So before 10 years, when I was using the Smartpls software, it was given as a trial version, and even the professional version is actually given as a complement. But now the Smartpls is not given as complement. It's like we need to purchase it. But one of the, it's like good about it, right? You can do both the covariance based and what you were doing in Amos and Lisrel, as well as the PLSM in Smartpls software itself. That's why it has gained some traction. And for the academician, they do give some 50% reduction in the amount. For example, I have purchased it. The actual amount for 1 month is 5,000, but I bought it for 2,500 or 2,600. So for academia, they are giving it. So it's like it is good to use PLSM because it is very easy to draw the model. And if you understand what is the concept, you can do it very well. So before going to the software, I would like to understand whether you all downloaded the software and got the license and installed it. Any of you didn't install? Yes. Okay. I believe that most of you have installed the software. Thank you so much. Okay. So before that, I would like to explain something about the latent variable and the observed variable. Is the screen visible? Is it a plain screen or are you viewing white plain screen now?
Yes, ma'am, we can see.
I mean, it's not full screen, but
okay. Is it so?
And one doubt I had in this, you mentioned about the PLSM. You were talking about CBSM, the sample size has to be large, whereas PLSM. So is there any kind of a limit or any kind of a formula to gauge when to, what is exactly the, say, the sample
the correct
size?
sample size. Okay. So generally for the sample size calculation, we do have a power formula, sir. So we do have a software which is free of cost. It's like you can download. When you search about the power, you can download it and use it. But it's like we generally used to tell the t-test is for some small sample size when the sample is less than 30. So it's something not like that.
No, I meant, for example, with respect to PLSM, is there any, say, sample size limit? It has to be, say, within say 380 or say within 400, you can use PLS. Is there
No,
any
sir,
hard
it's
and
not.
fast rule like that?
No, we don't have any hard and fast rule. We go with this power formula only. It all depends upon your model.
Okay.
It all depends upon how many independent variable and dependent variable you do have. And it doesn't make sense even if it is CBSEM or PLSM. But what is that? The CBSEM, you need more sample size. But in case of PLSM, you can get the convergence with a small sample size. That's all. But we don't have any hard and fast rule or any formula for calculating sample size, particularly for the PLSM.
Okay. Thank you, madam.
And one more thing I forgot to mention, it's like we have studied about the square. Generally, if we give a negative value and square it, we will get a positive value. Likewise, the PLS is very famous because the convergence is very easy. Even we give the negative value, it converts everything into positive value and runs. That's why we are getting the convergence very easily compared to the CBSEM. Okay. So before that, we will understand there are few terminologies in structural equation modeling altogether, not with CB or PLS. In structural equation modeling, we do have some terminologies. So we will see the terminologies. Okay. So you have a concept called latent variable. Okay. Latent variable and observed variable. Latent variable and observed variable. By any chance, anybody knows about latent variable?
I guess you are writing it with that letters are not visible, ma'am.
Is it so?
Yeah. Now it is visible.
Oh, when it is coming to a full screen, it is not visible. Okay, sir. Okay, so you have latent variable and observed variable. So how it is visible? Okay. So you have latent variable, and have you heard about latent variable and observed variable?
Ma'am, is it something like the endogenous and the exogenous factors?
That is actually independent variable and dependent variable. Okay, so let me explain. For example, you have a factor called customer satisfaction. Yes, and this customer satisfaction is indicated by a oval shape. If any of the variable is indicated by the oval shape, it means that it is a latent variable. If any of the variable is indicated by the oval shape, it means that latent variable. And this customer satisfaction is measured by some of the items. We generally call that as questions. This is measured by some of the items. We call them as question, but in research terminology, we call them as items. It is generally represented by this rectangular box. Yes, this generally represented by the rectangular box. This is said to be observed variable. Okay, this is said to be observed variable. Okay, so the customer, we take an example of customer satisfaction, where customer satisfaction is represented by the oval shape because we are not measuring customer satisfaction directly. We are measuring through some items. So the items which we are observing is represented by a rectangular box, and it is called as observed variables. And the variable which we are measuring, it's like latent means it is hidden. So it is hidden. So customer satisfaction is said to be the latent variable. Generally, we call it as LV, latent variable. Is that okay?
Yes, ma'am.
Shall we proceed?
Yeah.
Okay, so that is called as latent variable. This is called as observed variable. This is one terminology we generally use across structural equation model. So coming to what one of the other participant told about the exogenous and endogenous variable. Like in structural equation modeling, we do have a concept called inner model and outer model. So here you can see the inner model and the outer model. So the outer model is one where you can see this indicator to the independent variable. This is said to be the outer model where it measures the relationship between the independent variable and its concerned indicators, or the dependent variable with its concerned indicators. So the indicator to the variable relationship is said to be the measurement model or the outer model. While the relationship across this independent variable and dependent variable, or between the dependent, there are some instances where independent variables are connected. So the relationship between two or more independent variables with the dependent variable, or the relationship between two independent variables, all said to be the inner model or the structural model. So we have got two models. One is measurement model or outer model, which tells us the relationship between the indicator to the variable. We have an inner model called structural model, where it tells us the relationship between the variables, not with the indicator. Generally, we go with first measurement of the outer model, that is the measurement model, and then go with the structural model. So the first criteria is we generally go check with the measurement model, that is outer model, and then once it is satisfied, we will go for the inner model evaluation, or it is called a structural model, right? And here it is mentioned this dependent variable. Generally, the variable on the right-hand side is said to be the dependent variable or endogenous variable, and the left-hand side is said to be exogenous variable. As I told, this indicator all are represented by the rectangular box. It is called as observed variable, while this independent variable, which is measured through this indicator, are called latent variable. This side, the independent variables are exogenous. It's like the independent variable. Here, the dependent variable is also a latent variable. Yes? Shall we proceed?
Just one
You
small.
can repeat.
Yes.
I would.
Ma'am, can you please, like, the screen is not that clearly visible to us, like to me. So could you please zoom it out?
1 minute, 1 minute. Yes, sure. Is it visible now? Is it bigger now?
No, ma'am.
It is the same, ma'am. I think at the bottom we can see that zoom option there.
Okay. I'll stop sharing. I'll start it again.
And if you can repeat that once, would be appreciated.
Yeah, sure.
So I had a small question, madam, along
Yes,
the lines of what Prakash
Yes.
Kumarji is asking. You know,
Yes.
the outer model, which is the relationship between the indicators and the independent variables. Now, in a primary data scenario, primary data collection scenario, what is the independent variable? So say, for example, technology acceptance model. In technology acceptance model, one of the independent variables is whether the item or the technological item helps me do my work better. So that has different names by different researchers, but essentially it is basically, if I use this software, if I use this application, will my life be better? Will I be able to do my job better? Now, to measure that, we are using a scale, and in that scale, we have multiple items.
Yes.
So this indicator 1, 2, 3 are the items in the scale. And this independent variable is, let's say, this efficiency improvement, whatever. And then that efficiency improvement finally links to usage of technology.
Yes.
Okay. Understood. Thank you so much.
Yeah. Okay, sir. Yes, sir. Some people want me to repeat it. Now, is it this in full screen or not? Still, it is not visible.
Okay, it is the same, madam. It is the same.
Okay, 1 minute. 1 minute.
Madam, we can zoom our screen by ourselves also.
Yeah, you
So,
can, but
so,
wait. Is it visible now at least?
We are able to zoom in our page, madam. So it's visible now.
But I also can do it. It's okay.
Yeah.
Okay. So we'll start again. It's like in case of SEM, we have two models. One is outer model and the second one is inner model. So one is outer model and the second one is inner model. Where the outer model, where I have indicated here, it's like this line. This is said to be outer model, where it tells us the relationship between the variable and its indicators. For example, we have taken customer satisfaction as the independent variable and its scale. It's like the questions related to customer satisfaction. That relationship is said to be the outer model or measurement model. For example, you have customer satisfaction as one of the independent variable and customer loyalty as a dependent variable. And this is brand loyalty, for example, you take. Then the relationship between the customer satisfaction to customer loyalty and the brand loyalty to customer loyalty, or the relationship between these two independent variables, are said to be the inner model or the structural model. Generally, we start with the validation of the measurement model and then goes to the structural model. Is it okay now?
Yes, madam.
Ma'am, indicator means items, right?
I know indicator.
Yes. Indicators means items or the questions.
Right. So here I'm just revising. So here in outer model, we will check the relationship between items and the independent variable.
Yes.
And we are also checking the relationship between two independent variables. Am I right?
No.
No?
The outer model is only the relationship between the variable and its indicators. That's
okay.
all.
Not among the two independent.
No.
Okay.
The relationship between the variables is inner model.
Inner model. Okay.
Only with indicators and the variable, it is outer model. When it is between the variables, it is inner model.
Got it, ma'am. Okay.
Yeah.
It's
Any other doubt? Is it clear now?
So, ma'am, on the right hand side, when we see that dependent variable with its indicators 7, 8, 9, that is the inner model?
Also the outer model.
Outer model.
So leave dependent or independent variable. Don't worry about the dependent or independent variable. The relationship between variable to its indicators. That is the outer model.
Okay.
Irrespective of whether it's independent or dependent.
Ma'am, can you give some examples like independent variable group A, group B?
Okay.
Can you give some examples so that we will be able to understand that clearly?
Yeah, it's like I have a case study of it. I just don't want to explore it now. I will go to the hands-on and there I will explain. Is that okay, ma'am?
To understand it over here, just you can say that in an what is that?
Okay.
An independent variable.
Yes. Okay, I'll do it. Not a problem at all.
Yes, ma'am. Thank you.
Yeah. Okay. So, I can take one example. I'll take my own article. I think that would be good rather than going with other article. 1 minute. Let me take the article. Okay, I'll go with single example or else you'll get confused about it. Okay. Okay, so this is the model. It is actually one of the examples generally quoted in Smartpls. This is one model where the customer loyalty is a dependent variable, while the perceived quality and the customer experience are independent variable. Okay. So this perceived quality is measured through questions like whether you are happy with the quality, whether you are satisfied with the quality, etc., etc. So that questions are said to be indicator, where perceived quality is said to be the latent independent variable. Likewise, this customer expectation is a latent independent variable where it is measured by an indicator like how the experience of the customers. So this too leads to customer loyalty, where customer loyalty is measured by some indicators. Here, this perceived quality, customer expectation, and customer loyalty, all three are latent variables. So it is indicated by the oval shape. While the questions which we are, it's like giving to the respondents are said to be the indicator or the items. So now the perceived quality has got some questions. When you are finding out the relationship between this indicator along with this perceived quality and its indicators, customer expectation and its indicators, customer loyalty and its indicators. So this is said to be outer model. Irrespective of whether it's dependent or independent variable, the relationship between variable and its indicators or items of question is said to be the outer model. While the relationship between the variables, like the relationship between perceived quality to customer loyalty or customer experience to customer loyalty, or perceived quality to this customer experience, the relationship between the latent variables, irrespective of whether it's dependent or independent, that is said to be the inner model or structural model. Is that okay now?
Madam, one question.
Yes, sir.
See, sometimes, I think many times, we may not have questions directly measuring customer loyalty, isn't it?
Directly measuring in the sense I
Means
don't understand.
that endogenous latent variable and the indicator 789, those indicators 789 may not exist at all.
Then how will you measure, sir?
So through the independent variables. So we are measuring the relationship between the independent variables and the dependent variable, right? So we are interested in the inner model.
Okay. So it's not like that, sir. For example, if you have a dependent variable, what you are telling is about the latent variable. I'm going to come to the concept. Let me explain that concept too. So what you are telling is that this customer loyalty is not explained directly by these indicators, and this IV is only measuring it. That's what you are asking, sir, right?
Yes, madam.
But generally, IV, we are checking. It's actually, you do have confirmatory as well as exploratory. We do have confirmatory factor analysis and exploratory factor analysis. In exploratory factor analysis, generally, we will not do here in Smartpls or in SEP. We generally do it in SPSS. We have factor analysis, we'll just explore it and do a confirmatory factor analysis here. So, independent variables will be measured separately and dependent variables are measured by their own items. What do you mean by it is like somewhere, for example, you have this customer expectation, perceived quality, and this is one latent variable, this is another latent variable. Okay, I'll take my own example. Okay, so I did it in knowledge management. For example, knowledge management is actually a latent variable where knowledge management was measured by knowledge acquisition, knowledge storage, and knowledge sharing, etc., etc. So, what you mean by this? This knowledge management is not measured directly, while it is measured through this knowledge acquisition, sharing, etc., etc. So, this might be possible, sir. And this knowledge acquisition will be measured by this observed variable.
Correct.
Right, sir?
Correct.
This is not independent or dependent variable. We generally call it as higher order latent variable, sir. So what is higher order latent variable is like? For example, if you are not considering this Km and you are considering only this Km, it means you have only one level of latent variable. One level of latent variable where you measure through the observed variable. So it is called as latent variable approach. But when you have one more latent variable like Km, it is measured through this. This is said to be second order latent variable. This Km here is said to be second order latent variable. There is also third or fourth order latent variable. So I will find out an article. I have an article I misplaced somewhere. I'll send you where you have fourth order latent variable also. So I think you are asking this. Am I right, sir?
Yes, madam.
So this is said to be actually order, second order or third order latent variable.
So in this case also, this SEM will work, right?
Yes, sir, of course. The SEM will work. Again, this KA, it's like the knowledge sharing with its indicators. It's only said to be the outer model. While the relationship between this knowledge sharing, one latent, first order latent variable with the second order latent variable is said to be the inner model, sir.
Understood.
Is that okay?
Yes, certainly. Thank you.
Okay, sir. Thank you, sir. Yes. Anything else?
Relationship between the latent variables is the inner model, madam, and relationship between the variables and its indicators is the outer model.
Yes, yes,
irrespective of the independent or dependent, right?
Yes, sir.
It is
Yes.
immaterial, and if they are more kind of things, they are then second order, third order, and fourth order.
It's like if you add levels of latent variables.
Okay.
Different levels, even the relationship between the latent variable is called as only inner model.
Yeah, inner model. Okay. Thank you, ma'am.
Yes, sir.
Ma'am,
Thank you, ma'am.
Ma'am, kindly go to the previous slide.
Yes, sir.
Yeah, ma'am, in this, like indicator 1, 2, 3, with 1, 2, 3, we can get independent variable A. With 4, 5, 6, we can get independent variable B.
Okay,
With A and B, we can get dependent variable. Now, what is this 7, 8, 9?
Sir, it is not like this independent variable is called, it is like it is leading to dependent variable. This dependent variable is measured by some items or some questions. Here it is called as indicators. This independent variable is measured by some items. This is separate and this is separate. We are just checking in this relationship whether this dependent variable is caused because of this independent variable. This is causation relationship.
So arrows are correct or arrows are should be in some other way? Indicator
Which
to
arrows
dependent.
do you mean, sir?
Yeah, indicator 7 to dependent variable.
Sir, I'll explain about this. Again, we have two types of constructs. I'll explain about it. The arrows are perfect.
So,
yes.
It means we are getting some output from this dependent variable in the form of indicator 7, 8, 9.
No. So
No.
as of now, please pass that question. I'll explain about it and then you can, if you are not clear with that, because it's some other concept. I just don't want to confuse with that.
Okay, fine.
Okay. So shall we?
Yeah, madam, we can proceed, madam.
Okay. So everybody was asking about the arrow pointing outside as well as the arrow pointing inwards, right, sir?
Yes, ma'am.
Okay, so there is actually two types of model. I think I have a PPT for that. Okay.
And you'll be sharing this PPT with us, right?
Yeah, sure, sir. Sure, I will do. Okay. So here, if you see, the arrow is pointing inwards.
Madam, the
In
screen
case
is
of,
not visible properly.
1 minute. You can zoom it. I'll also zoom.
Sir, we can zoom it and see, sir.
Is it visible now, sir?
Yeah, it's visible.
Yes. Okay. So it's like when you see this exogenous variable like y1, y2, and y3, in case of y1 and y2, the arrow is pointed inwards and it is written, it is formative. So in the example, what I have shown, when the arrow is pointed inwards, it means that it is a formative construct. When the arrow is pointed outwards, it is said to be reflective construct. It has nothing to do with this is causing this or that is causing the other. So please remember that when the arrow is pointed towards the latent variable from the indicator, this is said to be formative. When the arrow is away, it's like outwards from the independent variable or the dependent variable, then it is said to be reflective. Now I will explain what is formative or what is reflective. Is that okay, sir? Shall I explain?
Ma'am,
Yes,
in that
madam.
Yes, ma'am.
one is y1 is reflective, the others all are formative, right?
Yes, sir. Yes, sir. Don't, it's like leave that. It's like when the arrow is pointed towards the, from the indicator towards the latent variable, then it is formative. When the arrow is from the latent variable to the indicator, it is reflective. Is that okay, sir?
Can you repeat the formative one, madam, once? When the arrow is
No.
from the latent variable to the indicator, it is reflective.
Yes, from the latent variable to the indicator is reflective, while if the arrow is from the indicators towards the latent variable is formative.
While the arrow is?
When the arrow is from the indicator to the latent variable, then it is said to be formative, sir. Inward arrow. You can also call this an inward arrow.
What's a latent
Okay.
variable?
Yes. Shall we proceed?
Yes, ma'am.
Okay. So now I'll explain what is reflective indicators. So the arrow which from the latent variable towards the indicator, it is called as reflective. Why it is called as reflective? Because this reflective items are interchangeable and they are linked to the construct through the loadings. Okay. In other words, when you, okay, I'll explain this. Okay. So here, for example, you take the same example, this KM. Okay, I'll take this KM as an example for reflective construct. Okay, you have this knowledge sharing. So knowledge sharing is actually a latent variable. In case of knowledge sharing, we do have some constructs where you measure this knowledge sharing. In this case, the arrow is pointed outward. So what type of model is this?
Reflective.
Reflective or formative?
Reflective.
It's reflective. So in case of reflective, for example, this is I1, indicator 1, indicator 2, indicator 3, indicator 4. So in case of reflective model, even if we remove this indicator 2, for example, we are removing this indicator 2 because after some analysis, we find it is insignificant, right? We can remove that. That is reflective model. Even if we remove that indicator, it will not make any alteration to this variable called knowledge sharing. Is that okay, sir? This is reflective. And once again, this indicator I1, I2, I3, I4 are all correlated. What is mean by correlation is that they are highly correlated, so that even if you remove one of the item, the behavior of the latent variable will not change. This is reflective. Why? This customer, for example, I'll take one, okay, I'll take a latent variable rather than I'm explaining something else. I have an article where okay, I don't have any formative construct. Anyway, I'll explain. I explain. If you didn't understand, then once again, I'll explain with a different example.
Ma'am, just now you showed that I1, those all are observed variables, madam?
Yes, sir. That is indicator. For indicators, I have used this I1 notation. That is indicator 1 and indicator 2, right?
So, madam, so see, the arrow pointing, etc., is just a matter of convention. But what I am asking is, how do you know indicator is reflective or it is formative?
Yes, it is only through the literature review we'll get to know whether it is reflective or formative. Based on the literature only, we can, it's like model it as reflective or formative, sir. So it is like we can't find it out. It's like we can't do anything. For example, if it is an exploratory research, you are conceptualizing it as the formative indicators. It means that I'll tell you what is formative indicator also. If it is a formative indicator, I represent this I1, I2, I3, I4. In that case, if you remove this I2, it doesn't mean that it will measure the same knowledge share. You should not remove, because the items are that the indicators are not correlated. So you should not remove, even if you remove one of the questions, or if it is a second order latent variable, one of the latent variable, then it will not explain the variable you are modeled.
So
but in case of, yes, sir.
Sorry. So can we say that if the indicators are not correlated, and if by dropping the indicators we are not getting a change in the whatever ANOVA or whatever we are trying to do, then we can say that that's a formative construct.
That could be a shortcut of it, sir. But
Okay.
that is not a scientific way of telling it is a formative or reflective. It is only through literature review we will get to know it's formative or reflective.
Okay.
We can't model this as formative or reflective. We can consider anything as reflective. That is not a problem at all. We can put together some of the three latent variables and tell that this three latent variable explain this fourth latent variable. That is not a problem. But if you are declaring something as formative, for example, I was working on one variable called brand evangelism. So, according to Bekra and Badrina, that is famous article where this, the brand evangelism is explained by the purchase intention and oppositional brand referral and positive brand referral. So there they have conceptualized it as reflective model. So what I did, I adapted that model, and when I ran that model, in my model, the purchase intention was not significant. So I have removed it. So I can remove it only if it is a reflective model. For example, we are taking some scales from already established scales. And if it is declared as formative, we need to treat that as formative and we should not remove any other items from there.
Okay, so maybe this is not the correct forum, but sometimes I feel that by doing that, we are copying other people's work. So what new are we doing?
Okay, it means that there are two types of research. The research what we are all doing is incremental research. Okay. So if you want to develop a scale, that is a different type of research, sir. For that, you need to go for scale purification and you need to go of different round of analysis, and you will not be using this structural equation modeling in case of scale development.
Okay.
That is actually different arena of research. This is actually not the scale development research. This is actually you are developing a conceptual model, and the conceptual model which already exists will include one more variable. Like making an incremental change either as an independent variable or as a dependent variable or as a moderator or mediator, and then we'll publish. For that type of research, generally we will go for structural equation modeling.
Okay, very good, understood. So because I had this question, I had attended another session, I had raised this question, but the answer was not so clear. And so I always used to feel that research is not so useful. You're copying other people. So what is the great deal?
What we are doing is generally as a researcher, we do have lot of goals. So we tend to do a discovery. But the social science research, even the experiments or what the science they are all doing, we are all doing only incremental research. We'll include one variable and see how it is affecting. Or else what we will see, we will take one variable from one article and 2-3 variables from the other article. We'll put together and see how it is changing that characteristics of the independent variable or the dependent variable. That is what we are doing. What you're telling is about the scale purification. When you want to develop a scale, for example, when you see the marketing article, there was a recent scale. It's like recent means 5-6 years ago, the mastered scale. I'll also send that article if you want. It's like there, the Justin Paul sir has developed actually the mastered scale. So you have to go for 3 or 4 rounds of survey, and you need to go for scale purification, expert analysis, etc. So that's very different.
Okay. Thank you.
Yeah, thank you, sir. Any other doubt? Anybody? Because this is actually the base of the structural equation modeling. Without this, just running with the software, anybody can do it. But you need to understand this and then only you can move forward. Anybody have any doubt?
So far, so good, ma'am. We can proceed.
Yeah, okay. Thank you, sir. Thanks for the confirmation. Okay, so it's like you have a formative model as well as the reflective model. In case of reflective model, if one of the indicators is removed, there is no problem. We can proceed with that. But in case of formative model, you should not remove the indicators. We should go with the same set of items or the latent variable. Okay, so here, sir, some of you have asked this dependent variable is causing this indicator 789. It doesn't mean that. I'm telling again, this dependent variable is actually the reflective indicator or a reflective variable where it is measured through the indicator 789. Even if you remove this 8, it is not a problem at all. The characteristics of this customer loyalty will not change. That's what the reflective construct tells us. But here in case of independent variable A, if you remove this indicator one, for example, in case of perceived quality, if you remove this indicator 1, then the independent variable should not be called as perceived quality in case of formative construct. So that is what the difference between the formative and the reflective construct. Even the way of validation of the formative and the reflective construct is very different. Okay, so we will move forward. Okay. Can you all please open the Smartpls? Can you all please open Smartpls? And come to this page. 1 minute. Okay. So when you come to this page, you can see about the workspace. Okay. So generally, when you have installed some software, you need to find out a workspace where you can store the data. Okay. So for example, when I click this recent workspace, it is showing me this e.smartpls. It means that I have assigned the E drive for saving the Smartpls files. It means that it is in the E drive I am saving the Smartpls file. Okay. When you want to change this drive, you can go for the new workspace and you can change the drive over here. Is it visible? It will be showing us Windows C, D or E. If you want to change the drive where you are going to store it, you can store it via this. When you press this new workspace, a pop-up window will open and you can find out in which drive you can make it as the new workspace, right? And then here in the Smartpls 4, as I told before, we have both PLSM and CBSM. So now they have improvised it and they have the PLSM as well as CBSM. They also have a plugin process where we generally plug in SPSS in case of moderation and mediation in CBSM. They have also introduced this plugin. So the goal or scope of this workshop is limited to PLSM and we will see how PLSM will be conducted. Yes? Can one of you please confirm?
Yeah.
Are we
In
good to go?
in my version, I don't have that process. I have that PLSM, CBSM, and regression.
Yeah, it's okay, sir. It's okay. It's okay. We are not going to do that. Anyway, if you have this window, then it's fine. The first work you should do it, you need to find out the workspace and you need to fix the workspace. That is what important. So once after fixing this workspace, you can go for the sample projects. Down you have a sample projects where you have PLSM, regression bar process and CBSM.CFA. Now we are going to see a sample project in PLSM. So I'm clicking this PLSM. So when you click this PLSM, you will get some of the sample projects. It's like corporate reputation. So there is one famous book called PLSM Book Primer. So there they have adapted this model. So this is actually the sample projects they do have. So we will start with this American Customer Satisfaction Index. So click this. When you click this, in the left-hand side, you will get this CBS, PRC, and PLS. So it's like CBSM, Path Analysis and Process, and PLSM. So please click this PLSM. Yes.
Ma'am, after the new workspace, now we have to go for this PLSM and we have to click on that.
1 minute. After moving to this, okay, you have set the directory.
Yeah, yes.
Okay, after setting the directory, I'm just going to explain a sample project.
Okay,
So the
we need
sample
not have to do it.
Yeah, no, now we will not do it. At the end, we will do it and close, and tomorrow we will have full answer.
Okay, ma'am.
Okay, so now we have the sample projects. You click this PLSM. When you click this PLSM, now we are going to work with this American Customer Satisfaction Index. When you click this, you will have in the left-hand side, you will have the CBS, PRC, and PLS. Please double-click this PLS. Once you double-click this PLS, you will have this model. So you have tools here. When you click this tools, it will disappear. So this is what. Okay.
Which tools you have to click, madam, after that? After you
No, it's like it will be a hindrance for you to view the model. That's why I click the tools in order to hide it. That's all. Okay, so this is actually the PLSM model we are going to. I think I have told you this perceived quality, this customer loyalty, satisfaction. So here, this is an improvised model where you have four. You have the independent variables and your dependent variable is customer loyalty. Here, you have a moderator called customer satisfaction. And you have a mediator called customer satisfaction between perceived value and customer loyalty. And you have customer complaints between customer satisfaction and customer loyalty. So before you go into this, I'll explain. Okay, so again, you go back. Okay. Okay. When you go and click this, you will get this model. Below that, you have a link. You have a link where when you click this American Customer Satisfaction Index, a sample data set and description, when you click this, it will go to the American Customer Satisfaction Index, which is published in, it's like updated and published in June 2023. Is the screen is visible? You please click that link. That link will lead you to a journal or article where the American Customer Satisfaction Index, a sample data set and description is given. So you go see for view PDF. You've gone there? Are we all on the same page?
No, ma'am.
Okay, so where were you?
Ma'am, first PLSM, if I click that, then I have to go to American Customer Satisfaction Index, right?
Yes.
Yes, I'm clicking that. Then next, madam.
Okay, where were you? 1 minute, I'll come.
Yeah, now I got example. You
got example. Here you have CBSM, path analysis, as well as PLSM. Click that PLSM.
Okay.
So when you click that PLSM, okay, so down you have the American Customer Satisfaction. Wait for 2 minutes. It will take time to come to that window. You got it?
Yes. Yeah, it came.
Yeah. So down you have this example shows the customers. There you have a link like which is highlighted in blue, the American Customer Satisfaction Index. Click that. When you click that, it will go to a journal. Like data in brief.
Yeah, the link is getting loaded.
Yeah, it will take time.
The American Customer Satisfaction Index.
Yes. Okay. So give view PDF and you will get this article. So this article explains you about the data set. This article will explain you about the model. The model is that the customer satisfaction, this ACSI, is it visible?
Yeah. The journal is here, ma'am. Like.
So go to the model, the ACSI base model.
Yeah. Okay.
Okay. So here the perceived quality, customer expectation, perceived value. These are all independent variables. Okay. So, and the perceived value is also, it's like an independent variable. So you know that there is multiple relationship between this customer expectation, perceived value, perceived quality. And there is also a relationship between customer complaint and customer loyalty. So you get to know about this data. Okay, I just wanted you to know about this data. So they have explained where they have asked, what is the design, etc., etc. So for that, I want you to understand. That's all. When you after this class, you please read through it and understand. Here they have done for, okay, I'm not going to touch the moderator or we will get confused. Okay, so you just go through this thing and come back tomorrow.
Okay.
Okay, so now we will move to this. Okay, so before explaining this, I will go to the next PPT, like where you have, is the PPT visible?
No, ma'am.
Not visible now?
We can only see the Smartpls screen.
1 minute. Yeah, I think now it is visible.
Yes, ma'am.
Yes. Okay. So this is actually taken from the primer of partial least squares. So as I said, it was given that the preliminary consideration of the PLS. It's like you need to find out the small sample size, the statistical power goodness. This is all the preliminary considerations. So leave that out. Come to the next where you have the measurement model assessment. So what is measurement model? Whether it's inner or outer. Whether measurement model is inner model or outer model.
I think it's outer model.
Yes. So generally we start with the assessment of the outer model, which is called as the measurement model. And once the robustness is checked, then we will go with the structural model assessment. Right? So in case of measurement model assessment, and I have told you about the reflective and formative. This reflective and formative is only within the measurement model because the reflective or formative is the relationship between the latent variable with its indicators. Do you understand? In case of structural model, you don't have any terminology called reflective or formative. Only in the measurement model, you have a terminology called reflective or formative. Right? Is that okay?
Yes, ma'am.
This
So
reflective and formative, yes, sir.
Measurement model is the outer model you said, and only reflective and formative happens in the measurement model.
Yes,
and
sir.
That
Yes.
you got the relationship between the variables and the
latent variables and its indicators.
indicator.
Okay, so the reflective or formative is only with the relationship between variables and the indicators, and there is nothing to do with this across the variables or within the latent variable.
So, madam, I have one question.
Yes, sir.
See, here we are checking robustness, etc. Now, we have already collected a lot of data, and now if we check the robustness and we find it is not robust, what do we do?
Okay, so we have a iterative technique, sir. Generally, the SEM works on iterative technique. It's like, I'll tell about that. I told you about the indicator removal in case of reflector. This iteration goes with the reflector. So we'll remove one indicator and check for the significance. We'll check for the composite reliability, Cronbach's alpha. I'll explain about that. And then it will improve.
Yeah, but Cronbach's alpha, we would have calculated and validated when at the time of data collection itself.
Yes.
Yeah, so because otherwise we wouldn't have collected.
Actually, the Cronbach's alpha, Cronbach's alpha has one problem with the sample size. When the sample size is very high, you will have a good Cronbach's alpha.
No, but
That's
sorry, but when we are collecting at the beginning of collection, we take a sample of 50 and check Cronbach's alpha, because otherwise, what is the point? After taking sample of 500, we'll check, and then it's not so good. Then what will do?
Yes, sir. But here, Cronbach's alpha is not actually the evaluation metric. The evaluation metric is average variance extracted, and you have composite reliability. So generally, we do have a problem with Cronbach's alpha that if the sample size is very large, even if it is not correct, the Cronbach's alpha will be very high. That's why we are not only having Cronbach's alpha, we do have composite reliability, irrespective, it is not affected by the sample size. So that's why we do have called composite reliability, where we will see the robustness of that outer model and then goes to the inner model. I do have a personal experience that I will remove one indicator and check for this AVE, that is average variance extracted and composite reliability, and then I will include it and I will remove one more indicator. I think when we are running this Cronbach's alpha in SPSS, we do have a checkbox called Cronbach's alpha if item deleted. It tells us, so likewise, here also we can do that iteration. So we remove an indicator and see how the composite reliability increases, how the average variance extracted increases, etc.
So I wrote a Python program to do that, Cronbach's alpha, and I did a loop to actually remove one by one and check that also. So I did not use SPSS at all till now.
Okay. So it's like for the past 4-5 years, even we are not using the SPSS because directly the Smartpls give all the results.
Okay. No, so I didn't know much about Smartpls, so I did Python on old-fashioned.
Okay. You do use Python for calculating the Cronbach's alpha. Okay. So this Cronbach's alpha, we do have many other measures over here. That's why we are coming to Smartpls. Okay. So this robustness, it's like we need to tweak the model. That is what the advantage of Smartpls. In case of CBSEM, if the model is not converging, then that would be a problem. So I have seen many researchers who went on collecting the data, adding more of sample, but the samples are not converging. So I feel that Smartpls is savior for researchers. So it converges the data. At least if you have 300 sample size, and we have the variables of 7 in numbers, in Smartpls generally it will converge. Maybe the goodness of it is different. Like you said in Python, when you see the supervised and unsupervised learning, also we will find out the performance evaluation metrics. And in order to increase the metrics, we will do some cross-validation, resampling technique, etc., etc. Likewise, we do have here. Yes. Any other doubt? Shall we proceed?
Yes, ma'am.
Yes. Okay. So in case of measurement model only, you do have reflective and formative. And the evaluation of reflective is something very different from the formative construct. As mentioned over here, it is mentioned that the reflective, in case of reflecting, you will look out for the loadings, Cronbach's alpha, composite reliability, average variance extracted, and the HTMT criterion. So HTMT is heterotrade monotrade ratio. So before explaining that, let us explain about the validity and reliability. Okay, so anybody, I think you all have heard about the validity and reliability. So what is validity and what is reliability? What is validity?
So,
So start with what is reliability? I think that is only one set of answers. What is reliability?
so reliability is basically when you are taking multiple measurements, when you are using a scale, does the scale measure properly for different people, right? So is it repeatable? Is the scale repeatable?
Okay. So this reliability is that whether the scales are reliable, whether it's measuring the indicator, it's like the variable or not. That is what reliability. Generally, we use Cronbach's alpha as a reliability measure. Yes. Then comes to validity. So what will we do with validity? Anybody heard about validity?
Yes.
Validity is the accuracy, ma'am, and reliability in simple words is a consistency.
Okay.
Accuracy versus consistency. If you are getting that, then your model is reliable and valid.
No,
So that you can proceed.
So one of your friends said the reliability deals with the questions adapted in the questionnaire, opting for testing its sanity. Yeah, completely agree.
So
yes, sir.
I would like to.
You should get the result. Same.
I would also like to add that validity is also whether you are measuring the right thing. So you may measure consistently, but you may measure the wrong thing. So are you measuring the right thing? So you have to get some expert opinion. You need to use your common sense, etc.
Okay. Yes, Prakash, so you said something?
I meant, madam, reliability refers to the consistency and validity refers to the accuracy.
Okay. So have you heard about different types of validity? You have phase validity, content validity, and construct validity. Yes, you have phase validity, content validity, and construct validity. So the phase validity, it's like the expert opinion you will get and you will write that you got the expert opinion. So the validity is established. Likewise for the content validity. But you have a specific term called construct validity. So in case of construct validity, you will check the accuracy of the constructs. And under construct validity, you have two types of validity called convergent validity and discriminant validity. Have you heard about convergent and discriminant validity?
No.
Okay, so there are two types of validity. Okay, I just... sharing seats. Okay, you have two types of validity. So validity is of two types.
Construct validity is the accuracy of the. You were saying about construct validity, no, madam?
Yes, construct validity.
It sees the accuracy of the constructs. And then you have got two types, convergent and discriminant.
Yes, it's not like two types. Under construct validity, we have convergent as well discriminant.
Okay.
Under construct validity, you have convergent validity and discriminant validity. Okay, let me explain what is convergent validity and what is discriminant validity. Okay, so you have a correlation table where, for example, you take the same customer satisfaction. Okay. You have the same customer satisfaction. You have some loading value and customer loyalty. You have, so take a correlation table. The correlation, I'll take the correlation table. I think that would be better. Okay. So it's like variable 1, variable 2, variable 3. 1, 2, 3. So this is across the variable. So in this case, across the variables, we should establish discriminant validity. So across the variables, we should establish discriminant validity. This is 1, 1, 1. Okay. Otherwise, it's 0.8, 0.6, 0.4, 0.3, 0.2. So when it is between the variables. It means that the variable 1 and variable 2 should not be same. It should be different. The measures of variable 1 should not be same as that of variable 2. So that is what discriminant validity is. But if it's the relationship V1 to I1, I2, I3, the relationship between the indicators to variables, that where you need to establish the convergent validity. You understand?
You'll have to repeat, madam, once.
Yeah. I'll write. Okay. So between variables, we need to establish discriminant validity. It means that all the variables are different. The variable 1, for example, the perceived quality is not measuring the customer loyalty, neither the customer satisfaction. That is what discriminant validity is. But within the construct, for example, within constructs, we need to establish convergent validity. So within the construct, we need to establish convergent validity. For example, in case of perceived quality, it is measured by some indicators. This all indicators should converge only to this PQ. That is perceived quality. It means that I1, I2, I3, all this should measure only PQ. That is perceived quality. That is said to be convergent validity. While the perceived quality is here, customer satisfaction is here, customer loyalty here. So this perceived quality should not measure customer satisfaction, and this customer satisfaction should not measure, customer loyalty. So here you should establish discriminant validity. Understood?
So this is for a formative case or reflective case?
It is for the reflective. Formative, we generally don't go for any types of validity. If you can see over here, for the formative, we will not go for any types of loading or etc. But again, this is a measurement model assessment. In case of measurement model assessment, for reflective only, we will do all these things.
So I
In
think
case of formative, it is different. We'll first go with reflective and then we will go to formative.
I think if you apply all of this to the way we measure things in corporate in India at least, then every questionnaire will fail.
I don't understand what you mean, sir.
It's okay, madam.
Yes, please.
Okay, so now I'm saying that the way we measure things in industry, especially service industry, if you apply these, all questionnaires will fail. None of them will pass.
Okay. So in case of reflective, we need to first check for the validity and reliability. So the reliability is through the composite reliability or Cronbach's alpha, where the validity you have this HTMT criterion. When you can see this HTMT, this is heterotrait monotrait ratio. Heterotrait monotrait ratio.
And this, you said convergent validity will be between variables.
Convergent means it's converged. Whether all the variables should converge as one variable, sir, that's not required and that should not happen. So only for the indicators with the variable, the convergent validity should occur. Between two variables, it is discriminant validity. One variable should be different from other.
Okay.
You might have heard about, I'll introduce the concept of multicollinearity. You have heard the concept of multicollinearity. What is multicollinearity? It seems, for example, the perceived quality should not measure the customer satisfaction rather than the customer loyalty. In that case, there comes the issue of multicollinearity. Yes, sir.
Yes, ma'am.
Okay, I think you need more explanation. That's what I can identify from the way you tell us. Okay, so if it is across variables, all the variables should be different. That is what discriminant validity is. While the convergent validity is that all indicators should measure only that particular variable and not the other variable. So the convergent validity should be established where and discriminant validity should be established where? My question again is that.
Convergent validity is between construct. That construct will be only related with its items or indicators. And discriminant
Okay,
validity
so whether it's outer model or inner model?
outer model.
It's an
So,
outer model.
yes, for convergent validity is for the outer model, where the discriminant validity is for the inner model. Right, that's what I just wanted you people to understand it. Okay, so this is HTMT. Okay, so in case of formative model, we will not take the loadings at all. In case of reflective model, we'll consider the loading. So the loadings is nothing but in case of factor analysis, we do have factor loadings. And in case of factor analysis also, we do have a cutoff of 0.5. So what does the 0.5 means in case of factor analysis? Why we have the cutoff of 0.5? What does that 0.5 indicates?
I mean, I think that is the confidence level. I'm not sure.
Level of significance.
Okay.
UL.
Okay. No. Yes,
Maybe
I
it's
think
like,
somebody is.
it's a ratio,
explain.
so 0.5 indicates that 50%.
50% of what? Explanatory power. We generally call that as explanatory power. It means that if one of the factor is 0.5, it means that 50% of the variable is explained by that one factor. If 50% of the variable is not explained by that one indicator, we generally do remove it. Do you remember that? That is what factor loading also over here. We do have a cutoff of, generally in case of reflective model, we check for the factor loading. And here we do have a cutoff of 0.7. We do have a cutoff of 0.7. I'll send you an article tonight where the cutoff values are all given. What is the cutoff for the loading, Cronbach's alpha, composite reliability, etc. But please take in mind in factor analysis, the same loading is here in reflective. Okay, so this is what the reflective is. We again go to the Smartpls.
Ma'am, can I ask something?
Yes, please.
Can you briefly explain, ma'am, what is factor analysis?
Okay. Shall we do it later, ma'am? Because it's like we'll do a hands-on and after the class, we will have one-to-one. You ask about it and I'll explain to you. Is that okay for you?
Yes, ma'am.
Yeah. Okay. Thank you. Okay. So, we are not going to draw the model. We just only see how the model and its characteristics are over here. So, you got this. You are here till here. So, already the model is all developed. Tomorrow, we will develop the model and see with one of the real-time data. The model is already available over here. So, once you have done with the model, you can go to calculate and you will have the standard algorithm. Once you go to calculate, you have the standard algorithm. Okay. Arvind sir, I will just reply to this later. Please don't mind. Okay. So here you go to calculate. When you see here, this blue color ones are called latent variables, while this yellow color ones are called indicators. So this is latent variable, this is observed variable. So imagine that the model is developed and you need to go to calculate and click the PLSM algorithm. You go to calculate and click the PLSM algorithm. So here you have a PLS setup where it is telling you whether it's factor or path or PCA. So PCA is principal component analysis. We are not doing the principal component analysis. Neither we are not doing a factor analysis. So it is default. So you don't change anything. It is in default path, and we need only standardized result. It will ask whether it's standardized or unstandardized or mean center. But here we need only the standardized result. So we'll have the default option, and you click start calculation. When you click start calculation, the calculation will run and you will get the output. Okay, so the calculation has run and you got the output. All are on the same page?
You said that you need to go to the calculate, right? And then select.
Yes. You go to calculate and click the first option, PLSM algorithm. Click that. When you click that, a pop-up window will get open. Have the default option. Don't change anything and give start calculation. When you give start calculation, the model will run at the back. Sorry, the model will run at the back and you will get the window like this.
I'm not getting it. I think it is student license.
Wait. Okay, it will run. It is taking some time. That's why you're not getting mostly.
Yeah, we are getting some numerical value on it.
You're getting some numerical value. First, I'll explain this model and then I will go. Okay, so here consider the perceived quality. Okay, consider perceived quality. You see this 0.943, 0.935 and 0.794. These are said to be the factor loadings. So tell me whether it is a what is that? Whether it's a formative or reflective.
Reflective.
Yeah, because the arrow is pointing away from the variable.
Outward.
It is reflective, outward. So hence it is reflective. So in case of reflective, we'll go with the factor loadings. And one more thing, we should start with the outer model or the measurement model first, and then only you will go to the structural model, that is the inner model. So the first condition is we are going to check the outer model. In case of reflective, the outer model, we need to check the factor loading, average variance extracted AVE, and the composite reliability, as well the HTMT. Okay, we'll go one by one. So here, when you see this is said to be factor loading. So what does this 0.943 indicates? That this perceived quality is 94. It's like this actually customer quotient. So the 94% of the perceived quality is explained by this customer quotient. 93.5% is explained by this overall, while this 79.4% is explained by the wrong Q. Right? So this is what the explanatory power, how much it is explaining. But when you consider across these three indicators, you can see this customer quotient and overall quotient is comparatively highly loaded, while this wrong quotient is, it's like weak. Do you agree to it? It's like it is a relative only. It is not like if it is greater than 0.5, it is good. It is good, but compared to the other two indicators, this indicators is measuring only the less of this. Is that okay?
Yes, ma'am.
Okay. So now I want to tell you again. For example, if your factor loading or this loading is greater than 97 or 98%, it means that you have a multicollinearity issue. You should not feel very happy that you got a very perfect factor loading. You should be worried that there is some problem with your model. So when your factor loading is more than 0.97 or 98, It is better to revisit the items again. But here it is not more than 0.97. So we are good to go with. Likewise, you see this as well as you see only the outer model. First, you see only the outer model. The factor loadings are shown over there. For example, you got this. This is only factor loading. Where is this? Yes, somebody call me.
No.
Okay.
Sorry.
Okay. So factor loading, but we need to get the information about the AVE, average variance extracted, composite reliability, etc. So for getting that, you need to click this Excel. Okay. Click this Excel and you will be asking whether you have to render model image or a plain layout or render graphs. The default option is render model image. It means that the Excel spreadsheet will be created with the model image over here. What I am giving export. Okay. Save it. I'm saving it in desktop. Okay. So it will get export. You can also save it in Drive. It's like cloud. So it is exporting. Now we are going to see the average variance extracted, etc. But have you seen when you go here near this dependent variable or independent variable, the R square is flashed, the composite reliability is flashed. Have you seen that? When you go here, can you see? It is showing us the composite reliability, average variance extracted, Cronbach's alpha, etc., right? So you have exported. So everybody exports, right? Are we on the same page? Yes, yes. Okay.
The thing is, like, that is not getting highlighted in my version. It is saying that too many records, professional license required.
Okay. Oh, it is too many records. So it's not working.
Yeah.
Okay.
So
It's
that
working, madam.
I think then for everyone it will not work.
No, it is working for us.
No.
It is
So
working.
It's working.
It's a
Yeah.
license issue. It's a
We have
license
download-
issue. You probably have the student version. You should take the download.
You have
No,
not
I-
downloaded the professional version, sir?
Yeah, I think that is.
So wrong installation you have done.
Yeah.
Okay. Okay. So when you go there, you have this final results. Click this path coefficient. There is an option called show. Click this show. When you click the show, you will get a path coefficient where you have seen some values over the arrows we have explained, right? That is what given over here.
I can't see where is it show?
Path coefficient is there. After that, you have show.
I can see only select all and export as image on the arrows, and on these variables I can see results R square adjusted, etc.
No, so have you exported the data to Excel?
Yes, I have done that.
Okay, and then Excel will open.
Yeah. Okay. Excel is open.
Okay, the Excel is open. The Excel will be like this. This navigation page will be the Smartpls report.
I can't see your Excel. Maybe you are sharing.
Is my screen is not visible?
It's visible,
You
ma'am.
can see the Excel sheet, madam.
Okay.
Yes.
Path coefficient. Okay. Then
Yes, you click the path coefficient.
Okay. Path coefficients. Okay, sure. Okay, so the matrix. Okay, so it's a two-way matrix, comp, Q, etc.
Okay, so now we are not going to work with the path coefficient anyway. First, we will go to construct reliability and validity. Okay, so I've explained about the loadings, keep it aside. So first, we will go to construct reliability and validity, which is available in next quality. Under quality criteria, you have construct reliability and validity. You click that show, you have a construct reliability and validity.
Where is it, madam? I cannot see that.
Okay, in the navigation, go down, sir. You have final results. And go to navigation. In the first sheet, you have navigation. There down, you have quality criteria. In the quality criteria, third one is actually construct reliability and validity.
Okay.
Click the show.
Okay. You get R square adjusted.
When you go show, come down, you have Cronbach's alpha, reliability, composite reliability, and average variance extracted. This table, sir. This table.
1 second, I have to
The
move
table I have highlighted.
construct reliability and variability. So that is
The construct reliability and validity. Now, we need to first see the average variance extracted. We need to first see the AVE, which is average variance extracted. This Cronbach's alpha, generally we do find it in before our main study itself. So the Cronbach's alpha is, it should be greater than 0.7. And it's like we do have a problem that it should be greater than 0.7, 0.8, etc., etc. But in case of research, you are taking your scales or extracting your scales from one another article. In the article where you have extracted the scales, please see the Cronbach's alpha value of the scale in that article. That is your cutoff. For example, if the original, for the original scale itself, if the Cronbach's alpha is 0.75, please don't expect your Cronbach's alpha should be greater than 0.75. And we do have a cutoff. There is no cutoff. It is based only on the research and on the original scales. So after Cronbach's alpha, come back to composite reliability. Okay, so the cutoff for the composite reliability is that it should be greater than 0.7. It should be greater than 0.7. So what we are checking is that we are checking the robustness of the outer model. The robustness of the outer model is checked first through the construct reliability and validity. Not only the outer model. Before that, when we have SPSS itself, this is all the preliminary condition. We will check and then only we will go for the validation. So the preliminary check starts with the Cronbach's alpha and then go to the composite reliability. If the composite reliability value is more than 0.7, we are good to go. And then you go for this average variance extracted. Again, this average variance extracted should be greater than 0.5. Okay, so we were discussing something about the higher order latent variables. Do you remember that? We were discussing something about higher order latent variables, like first order latent variables and second order latent variables. When you use the second order latent variables, there is a high tendency that your AVE could be less than 0.5. When you have a second order latent variable, there is a high probability that your average variance extracted is less than 0.5. Personally, I do had this issue when I was doing my PhD. So in that case, we do have a citation where even if the average variance extracted for the second order variable is less than 0.5, if the composite reliability is greater than 0.7, we are good to go with the outer model. Yes. Yes, is that okay?
So second order variable, if the AV is less than 0.5, but composite reality is greater than 0.7, we've got a green signal to go ahead.
Yes, 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 yes. We do have a citation. I'll send the citation once tomorrow at the end of the class. I do have the citation because it's like generally we will not directly tell that this is acceptable. We need to cite it with the journal article. Then only you will not get any question regarding your rigor. So I will send you that citation also.
So
We'll
what
cite your
happens?
name only, madam.
Sorry, sir?
We'll cite your name only.
No, that's not actually. Even the books, if you cite a book also, they'll not approve. The A-star journals generally require a journal article which is peer reviewed. Yes, Arnab, sir.
So suppose we don't get a good composite value, then what do we do?
If you don't get a good composite reliability, our model, we are good. It's like we are safer side. We are having a reflective model only. So we can remove one indicator. Again, we run this model and check the composite reliability. And you check whether the composite reliability is improved or not. For example, you have indicator 1, 2, 3. You remove the indicator 2 and check. What, for example, if the composite reliability is not increased, include the indicator 2 and remove the indicator 3 and test. So likewise, you have many trial and error version. It is again, it's not a one-day work. It is so challenging that you need to find out the citation, how we can publish this paper, etc., etc. Yes, sir? Yes.
So preliminary assessment is Cronbach alpha, composite reality, and average variance.
Composite reliability and average variance extracted. I'll only explain about this discriminant validity. Okay, so in the same page, when you go down, you have discriminant validity. Okay, you have discriminant validity. So in case of discriminant validity, we generally started with Forner-Lacker criterion. So there is a concept, there is a scientist called Forner-Lacker. What he told is that this one, you can see this one on the diagonal, 1.826, and you have 0.923, etc., etc. So according to Forner-Lacker criterion, the diagonal elements value should be higher than the off-diagonal elements. For example, in case of customer experience, CUEX, when you see this, the diagonal element is 0.826. But the off-diagonal elements, when you see this, it's 0.611, 0.525, etc. So it means that you are good to go with, and there establishes the discriminant validity. And once again, in case of Smartpls, it is not required to go and check the cutoff, because if you have any alarming values, it will be indicated by a red color. When you see this HT-MT ratio, can you see this red color one? It means that it's alarming and it's not acceptable. But if everything is in this black color text, it means that it is acceptable. So according to the Forner-Lacker criterion, it means that there establishes a discriminant validity. So the discriminant validity is for what?
Between the constructs.
Okay, the discriminant validity should be established between the constructs. So tomorrow I will explain about the heterotrait monotrait ratio, because it's like before 5-6 years we started with Forner-Lacker criterion, but nowadays the journals are asking for heterotrait monotrait ratio rather than the Forner-Lacker criterion.
So I'll explain is for variables, or constructs.
Variables or construct are one and the same. This is indicators. That is all indicators. That is not construct. Construct or variable or independent variable or whatever you say, that is all only the variable.
The indicators are items in simple words.
Indicators are said to be items.
So for convergent validity, it is between construct. It is between variables.
Yes, sir. Yes, yes.
Between variables.
Yes. Convergent validity is between the items.
Items.
Between the items. Convergent means it should converge. It should measure only one variable. That is what convergent validity is. While discriminant validity is the three variables should measure three different experience or three different measurement.
That is between items and this is between constructs.
Yes, yes, yes.
Ma'am, one more doubt. Actually, last year I had this professional download, ma'am, of Smartpls, but now it says that you cannot because you have already used.
Yes,
so is there any alternative, like a crack version or like that, madam?
No, crack version is not available in Smartpls, sir. You can use with one another laptop and with a different mail ID.
But with the same laptop, can I use a different?
You can't use it. You can't use it.
No, you cannot, because see, the license is validated at the provider's end. So their server has your laptop's hardware address.
Okay.
You can't do that.
So you need to use a different laptop with a different email address also.
Okay. Desktop
Then
also
you
will work
can
out,
go
madam?
for- Sorry, sir?
Desktop will work out?
No, nothing will work. So it is a hardware address that they're checking for your hardware address. So
No. Suppose if I use in this laptop and now I download in a different desktop.
No problem.
That's possible, sir. But when you are downloading, you will be getting a license. For that, you will be entering an email ID.
That email ID has to be different.
Should be different.
Okay.
Because they are both checking the hardware as well as the mail ID.
Yes.
You can create a new mail ID and you can give.
So no citation for this, madam?
No citation in the sense?
Just on a lighter note, as you told about the 0.7.
So the only citation is money. You can pay the license fee, no problem.
No, ma'am, as you told, ma'am, if it is less than that and then you can just cite that journal, I just thought of.
No, that's not possible, sir. Yes. So shall we end today's session with that? It's like because it's already 9, I just don't want to disturb your dinner. There is more to cover. It's like without covering this preliminary, I can't go directly to mediation and moderation. And I do understand that many of you don't have the basic understanding of. That's why I started with the basics. So tomorrow what we will do, I will send you the data set beforehand. We will do with the model. I will send you 2 data set with reflective as well as formative. We will run the model and see the reflective and formative. And we will do one multi-group analysis. That is the moderator analysis and the mediator analysis. Is that fine?
Sure.
Yes, ma'am.
Okay. Yeah. Okay.
Good evening, madam. Are you